This video will discuss how to write the equation of piecewise functions. And in particular, we're only looking at linear pieces right now because those are simpler to write and we should know how to write the equation of a line. In case you forgot how to write the equation of a line, though, here are the steps. Our first step is we're going to identify the slope of each part of the graph. So generally speaking, with a piecewise, you have more than one piece. So if we look at this first example, you have this line here and this line here. And we need to identify those slopes on both those lines. Let's do that real quick. On this first one, which is the red one, if you take your 2 points that are given here and you count your slope, you count up 1, 2, 3, 4, and 5. So you go up by 5 and over by 1, 2, 3, 4, 5. Up 5 over 5. And the simpler way would have just been go up 1 over 1, up 1 over 1. You see that your slope for the first line, m is equal to 5 over 5, or just 1. For the other line, now you're going up and to the left. So we're going to go up 1, 2, and we're going to go over 1, 2. So my slope here is I go up 2 to the left 2. That means negative 2. And 2 over negative 2 is equal to a negative 1. So your first step is to identify those slopes. Next step, after you do that, we're going to find our y-intercepts. We can see that the y-intercept of the red graph is just going to be here at positive 1. So the b here is positive 1. If we continue this graph on, which was slope was up 2 over 2, we see that this graph is also going to have, or I'm sorry, yeah, up 2, or actually up 1 over 1. So we're going to go up 1 over 1. We see our y-intercept there is going to be at 0. So we have the y-intercepts there from the graphs by continuing the slopes that we've already found. Now, I'm going to erase all this so we can see it. So what we've done is we've identified both parts of the graph, where this is the equation. The first one is y equals, we said 1x, or x plus 1. The other equation is y equals just negative x plus 0 when we lower it to 0. So there are your two equations. So for the piecewise, we'll write like this. F of x is equal to the first equation we said is x plus 1. The other equation is negative x. Now we need to define the domains. So we've written our equations in terms of y equals mx plus b. Now we're going to define the domains. So to identify the correct domain in which the graph is included, notice here the lowest x on this red function is at negative 4. And this closed circle means to include the negative 4. So we're going to include this negative 4. And we're going to graph this function all the way to the largest x on this graph is 1 for that particular function. And we're including 1. So when we write this, this will just be negative 4. And we're going to include negative 4. That's what the less than or equal to means. So negative 4. And you put the x in between because your x values are ranging, your x values are in between negative 4 and 1. So your x will go in between this. We're going to include the 1. This is the first part of the domain. For the other one, same process. We see now that on this particular graph, it's going to go from here, from there at the 1, and all the way to here at the 3. But this has an open circle at 1. And the reason it's open is because it's closed at 1 on this function. It has to be open here because this is a continuous function. We want this, if they're both open or both closed, and it's not continuous because you're defining on both functions. So we need one to be open and one to be closed. This one's open, that one's closed. That means this function is continuous. And all the piecewise functions you'll graph will be continuous. So again, this time it'll look like this though. We're going from 1, where the x's are in between 1, and you don't include the 1. So I'm sorry. So this is not part of it. So it should be written like the 1, don't include it. x, but we're going to include the 3. And again, remember, this symbol means not to include because there's no equal underneath it. This one means to include because there's an equal underneath it. And this is the piecewise function for this particular graph.